This is our second video on math for AP Physics, for AP Physics 1. And this one is going to be on the laws of sine and cosine. So this is also very important for AP Physics 1 and AP Physics 2. We're going to be using this all through the two courses if you're taking the two courses with me. So let's look at laws of sine and cosine. So when you're solving a right triangle, you can use Pythagorean theorem. So for Pythagorean theorem, you have C is equal to a squared plus b squared, and you can plug in the numbers that are unknown to solve for the unknown numbers or angles. So if I, let's say, wanted to find what this part is equal to, let's call it this C. It's the opposite of the right angle, so I would have C squared is equal to 4 squared plus 8 squared, and I would solve for C. If I wanted to find what this angle is equal to, let me call this one is A, B, and C, the corners of the triangle. And then for A, the angle is going to be called alpha. This is alpha. For C, I'm going to call this angle gamma. So C is usually called gamma. And for B, usually is called beta. So it looks something like this, beta. And I want to find, let's say, alpha. If I want to find alpha, I can use check functions. The opposite of this angle is 8, and the adjacent of this angle is 4. So I can use tangent, which has opposite and adjacent, and I can say tangent of alpha is equal to 8 over 4, which is 2. I did not solve what alpha is equal to, but I want to solve what alpha is equal to. So what I'm going to do the inverse function of tangent. So alpha is equal to inverse function, so it's tangent with a -1. It doesn't mean 1 over tangent, it means inverse tangent of 2. So tangent is a proportion, we talked about this in the previous video. Tangent is a proportion of the opposite side of a triangle, right triangle, to the adjacent side of the right triangle, and that proportion is equal to 2. And only for one specific angle, tangent of those two sides, proportion of those two sides is equal to 2. So to find what that is in degrees or radians, what that alpha is equal to, I have to take the inverse function. Another inverse function name for E is arc tangent of 2. In your calculators, you have tangent with a -1, and again, tangent with a -1 is not equal to 1 over tangent. So be careful with this part. And so I want to find what arctangent of 2 is equal to. So I'm going to do inverse function in my calculator and see what that is equal to. Change it to degrees because we're going to be using right now degrees. In most of the time, we're going to be using degrees, not radians. And if you're in calculus, you just have to switch between the radius and degrees all the time. And so arctangent of 2 will give me 63.4 degrees. Now, what if I wanted to solve for gamma? So I want to solve what C is equal to C angle right there. I want to solve for gamma. I'm going to do the same. Tangent of gamma is equal to, opposite of gamma is 4, and adjacent of gamma is 8. And that is equal to arctangent, or tangent with a -1 of 1/2. So because this number is 1/2. So I'm going to do on my calculator arctangent of 1/2, and that gives me 26.56 degrees. So this works with right triangles. I can solve for every single angle, or I could even find, I should say, I messed up right here. So I'm looking for gamma. So this was gamma. Gamma is equal to arctangent of that and equals to the angle. I could also solve for gamma. I would say gamma is equal to the total sum of all the angles in the triangle is 180. I know beta is 90, so that's minus 90. And I found alpha is 63.4. So the rest what's left is 26.56. Or it would be, if I didn't round, 26.6. So you can solve using Pythagorean theorem and sine, cosine, and tangent functions for right triangles, but you cannot do the same thing for the triangles that are not right triangles. So if you don't have a right triangle, how do you solve your triangle for all the angles and sides if you don't have the right triangle? So then you have law of sine and cosine, and your Pythagorean theorem is actually just a little part of law of cosine. It's just missing one part, and I'll show you which one. Otherwise, it's just the law of cosine. So let's look at the law of sine and cosine and how to use them for the example of the problems. So if you don't have the right triangle and you have to solve a triangle for all the angles and all the sides, the unknown ones, you have to use law of sine and cosine. So again, I'm gonna look at the triangle. So here is a triangle, and it has the angles of A, B, and C, but I don't call my angles A, B, and C. So the angle A, I'm gonna call alpha. So what you see here is alpha. The angle C, I'm gonna call gamma. So this is gamma. And the angle B is gonna call beta. So this is beta. The side opposite of A is called OA. And the side opposite of B is called B. And the side opposite of C is called lowercase c. So this is how we write our triangle with all the sides and angles. And then the law of sine says that the sine of alpha over A is equal to the sine of gamma or beta over B, and equals to the sine of gamma over C. That's all it is to it. It's pretty easy to use. You just have to know when to use it, and I'll talk about it in a second. So that's the law of sine. Easy to remember. And for the law of cosine, and I'm going to skip and not derive the law of sine and cosine for you. I did this in the past when I was teaching trigonometry class, but let's look at only for physics. You don't have to know the deep sides of it, of mathematics. You just need to know when to use it and recognize the cases and when to apply the math that you know. For the law of cosine, I'm going to rewrite it for you so it's easier for you to understand. So you remember that I just explained to you that the angle C has the opposite of it, C side, the beta has the opposite B side, and the alpha has the opposite of A side. So I'm going to say C squared is equal to A squared plus B squared. That is your Pythagorean theorem. Minus 2AB cosine, it's the law of cosine, gamma, because C comes with gamma. If I want to solve for A squared, I'm going to say it equals to B squared plus C squared minus, again, BC, 2BC cosine of alpha. B squared is equal to A squared plus C squared minus 2AC cosine of, what do you think it is? Yes, beta. And I should have written this one alpha, right? Alpha. So that is the law of sine and cosine. And then when you have the right triangle, if this is C and this is C and this is gamma, 90-degree cosine gamma becomes a 0, and you have Pythagorean theorem. So if this is A and this is A and this is B and this is B, then this is your Pythagorean theorem, because your angle gamma is 90 degrees and cosine of 90 degrees is 0. Now, when do I use my law of sine and cosine? You can use them only in specific cases. And if you choose the wrong law of sine and cosine, you just cannot solve the problem because you don't have enough known to solve the problem. So I use my law of cosine, and it's kind of tricky. My law of cosine I'm going to use when I have side, angle, side, and side, side, side. So I use the law of cosine when I have 2s on both sides. So if I have sides, angle, side, and if I have side, 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 I'm going to use the law of cosine. For everything else, I'm going to use the law of sine. And what cases do I have? I have side, side, angle. I have angle, side, angle, and I have side, angle cases left. So for all other cases, I use the law of sine. And only for when I have side, angle, side, and side, 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 I'm going to use the law of cosine. Here's the first example. I have to solve for beta. And looking at this problem, I will note everything that is given. I have angle, and then I have side and side. Or I have side, side, angle. So if I have side, side, angle, I have to use the law of sine because I don't have SS on both sides. So for the law of sine, I have sine of alpha over A, and my A is 47, yes, because this is C, this is B, so this must be A, and 123 is alpha, so sine of alpha over 47 is equal to sine of beta over B, which is 23, and equal to sine of gamma over C. Because gamma and C are both not given, so I don't have to include this into my equation. What I have now is alpha, which is 123. Alpha is 123. And I have to solve for beta. So I'm going to cross multiply. If I cross multiply, I have 23 sine of 123 degrees is equal to 47 sine of beta. So sine of beta is equal to 23 sine of 123 divided by 47. And let me plug in the numbers and tell you what that is, and then we're going to use the inverse function to find what beta is equal to. So I got 0.41, but I need to find beta, the angle. So make sure that your calculator is in degrees because we need the angle in degrees. We already have degrees, so we need it in degrees. So beta is equal to arc sine, or sine with the inverse function, of 0.41, or you can write it as arc sine of 0.41, which gives me 24.2 degrees. So what I needed to do here is to recognize what case it was, and then because I know which formula to use and how to use it, I was able to solve for the angle that they asked me. And I can use the rest to solve for the side C or for the angle gamma and so on. Here's one more question. In this question, I have a triangle and they give me all the sides. So because I have the case which is side, 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 I have two s's on both sides, I'm going to use the law of cosine. And I need to solve for alpha. So that means this is my A, and it doesn't matter which one is by my B. So I'm going to call this was B, and this is C. This one is C. So now, because it's A and alpha, I'm going to write as A squared is equal to B squared plus C squared minus, it's BC, 2BC, and then cosine of alpha. And I'm solving for alpha. I wrote gamma. And I'm solving for alpha. So now I'm going to plug in my numbers. A is 15 squared is equal to B squared, which is 6 squared, plus c squared, which is 13 squared, minus 2 times b, c, and cosine alpha. I'm solving for alpha. Now, if I plug in all my numbers, I will get cosine alpha is equal to 0.128, and I need to solve for alpha. So alpha is arc cosine, so I'm gonna do this one of 0.128, or I can do alpha is equal to arc cosine of 0.128, and that is equal to arc cosine of 0.128 is 82.6 degrees. Let's look at one of the questions where we use the law of sine or cosine to solve the problem. In the figure, two people are pulling on a stubborn mule. What is the single force that is equivalent to the two forces in unit of newtons? The force is going to be measured in newtons, and the direction of the resultant force. And when they say direction of the force, that means it's the angle. So I'm going to write the forces that are acting. So I have one force in this direction, and that one is 30 newtons. And then the other force is 40 newtons. So this one is 40 newtons. And the angle that they make, so this angle is 40 degrees, and this angle is 20 degrees. That means the angle that is left right here, so this whole line is 180 minus 60, so this is 120 degrees. And I'm gonna complete the parallelogram to add my resultant vectors. So I'm gonna complete the parallelogram. So this one is parallel to 40, this one is parallel to 30, and my resultant vector is gonna be this vector. So this is the actual direction of the mule. So one man is pulling one way 40 newtons, the other one is 30 newtons, and the mule is actually moving in this direction where the resultant red force is. So I need to calculate that force, but at first I need to know what my angles are so I can use the law of sine or cosine to solve the problem. So I'm going to look at this angle is also 120. It's a parallelogram, so I have 120 and 120. And in the parallelogram, the sum of all the angles is 360. So I have 360 minus 2 120s gives me 120 degrees. And this 120 degrees needs to be split between this side, this angle, and this angle. So that means this one is 60 degrees. Now I'm going to look at this triangle right here. So this is 30 because it's parallel to the force of 30 newtons. And this is 40. And I have 60 degrees. So what I have is, I have side, angle, side. So because I have side, angle, side, I can use the law of cosine to solve this question. So it doesn't matter which one I choose, my A and B and C. I can say the red one is C. So I'm going to write C squared is equal to 30. I wrote degrees here. This is 30 newtons. So this is 30 newtons. And this one is 40 newtons. So it equals to 30 squared plus 40 squared minus 2 times 30, 40 times cosine of 60 degrees. So my C is equal to, and C is actually the force, the F, the square root of 1300. So C or F is equal to 36 newtons. Now I want to find the direction. In the direction, I mean, what is this angle? I know this little angle is 40. So if I only could figure out what that angle is, together will give me, let me call this angle theta, the red one, angle theta. So to find this angle, the little angle, let me call it, I do not know, alpha. I can use the law of sine because I have side, I have angle, side, and side. So for angle, side, side, I can use the law of sine. So I'm gonna say sine of alpha over the opposite side, 30, is equal to sine of 60 over the opposite side is f, that I just found out is 36. So sine of alpha is equal to 0.72. Then alpha is equal to arcsine of 0.72. Then alpha is equal to 46 degrees. So now if alpha is 46 degrees, then this whole angle theta, so that theta is 86 degrees because the 40 and 46 will give me 86 degrees. But how do I write my answer? So my answer, the final answer is, the resultant force is 36 newtons at, and if I think that this is my compass, this side is up is north, left is west, and right is east, and down is south, then the angle that I'm looking at is it is 86 degrees north from east. So north from east is going to be written as north of east. So instead of saying from, look at it as from. So you move north from east 86 degrees. So the mule is going to be moving, going to be pulled from its course in that direction at 86 degrees north of east with a force of 36 newtons as a resultant force. Here's another example. Airplane is flying at 35 meters per second at 30 degrees north from east. So you see this angle, angle 30 degrees north from east, or north of east, and the wind is blowing north at 25 meters per second. Find the speed and the direction of the plane, the plane's resulting flight. So I need to find C, which is the resultant. And you again see it's a side, angle, side. So I have side of 35, angle 120, and side of 25. Oh, how do I find angle 120? Because they don't give me that information. They give you 30 degrees, right? And I'm gonna look at this triangle right here. This is 90. So if that is 90, then this is 60. The top angle of that gray triangle is 60. Then what's left is 120. So I'm gonna use the law of cosine, and I have only 6 minutes left, so I'm gonna pause it and write the equations and then talk about them. And you should try to solve this question without me solving. So write the equation how you would write law of cosine for this problem. So here I have c squared. I'm looking for c. The direction of the airplane is equal to a squared plus b squared minus 2ab cosine of gamma, because it's c, so it is gamma. And I choose my a to be 25 because I see that they give me alpha. So because alpha is given in this corner of the triangle, then my 25 is my A, and then my 35 is B. Then I'm going to plug in all the numbers and solve for C, which is the resultant velocity of the airplane. So the resultant velocity of the airplane is 52.2 meters per second. Now I have to find the direction of this airplane. So if I'm looking for the direction, I'm going to be looking for this angle in green. So in order to find that angle, I need to find this little angle right there, which is alpha, right? This angle alpha. And I'm going to add it to 30 degrees that is given. So 30 degrees is given. And that is going to be my direction. So let's find alpha. I can use the law of sine. So I'm going to pause it again. And you try to write your equation for sine equation. Because I can use, I have angle side now. I have angle side, so I can use the law of sine. So I have sine of alpha over 25 is equal to sine of 120 over C, the opposite of angle 120 is C, which is 52.2. So I get sine alpha is equal to 0.41. And then try to find alpha from what you know already. How do you find alpha using your calculator? So I hope you did arc sine of 0.41, the number we just found. And then that gives me alpha of 24.2 degrees. But the whole angle at which the airplane is off its course, or the direction of the airplane. So the direction airplane, I'm going to call this angle theta. So that theta is equal to 54.2 degrees. So the final answer is the airplane is flying at 52.2 meters per second at 54.2 degrees north of east, which means north, that's the direction north, and this is east. And this is north, so it flies north from east. So this would be your final solution for this problem. One more last important part that we need in our AP Physics 1 and 2 as math base is how to add two vectors. So if I have a vector D and a vector E, and I want to add these two vectors, I can use tip to tail rule, where I have my vector D and I add vector E as its tip to tail, and my resultant vector is going to be this one. So that's the sum of two vectors. Or I can use a parallelogram. So if I have the way I just did with the problem with the mule, I have one vector, I have another vector, I can construct a parallelogram, and my resultant vector is going to be this one. So that is parallelogram rule for addition of two vectors. So this is important to know for AP Physics 1 and 2. And here is one more thing that you really need to know. We're going to do this in AP Physics 1 when we start dynamics. So if you have a resultant force, maybe this is F, resultant force, and you can break this into two forces. You can call this one Fx, and you can call this one Fy. And if you have an angle, let's call it theta, then your sine theta is equal to Fy over F, and your cosine theta is equal to Fx over F. And so what's important to know here is this. You can rewrite Fx is equal to F cosine theta, and you can write your Fy is equal to F sine theta. So the one that is opposite of the angle, we're going to write as F sine, and the one that is adjacent to the angle, we're going to write F cosine. And they called the horizontal and vertical component of the vector F, and they make the right angle. So it's like a projection on the x and y axis, the vector F. And that's it for this video. And this was the last video on mathematics that we need to know for AP Physics 1 and AP Physics 2. Of course, you need more practice, and you can find all the practices online. So do the practice questions online, and then if you need more questions, you can always email me and ask me to which questions you want me to solve in details. And then use step-by-step problem solutions for guiding you through the problems.